Hi, I'm Caitlin Bryan, and I am going to be talking about big data applications for emergency response. Natural disasters have continued to increase in both frequency and impact over the last few decades. This has resulted in an increased need for emergency responders to react in efficient ways as the population continues to grow. In order to achieve the most efficient and effective response, several tools need to be utilized. One such tool is the concept of big data analysis. Big data has been defined as data that has a large volume, possible variety within the data, high velocity, and variability of the data. Data of this magnitude can be processed and analyzed to create real-time data, allowing for decision makers to make accurate and effective decisions that could possibly save lives. There are several aspects of big data analysis that can be useful to decision makers in emergency response, one of which involves remote sensing. This entails constant data being received that pertains to the atmospheric and conditions that include atmospheric pressure, weather conditions, and chemical levels. The availability of remote sensing images can allow agencies to identify what is happening in real time and where most of the severe damage has occurred. Another form of big data analysis involves data mining of social media accounts. Through social media, agencies can identify and track areas that are affected by a specific disaster. In other words, agencies can search for keywords and hashtags related to a specific disaster. One example would be Hurricane Sandy, where FEMA used Twitter feeds and Instagram photos to track the status of those affected by the storm and determine where supplies may have been needed. One example is the picture that you see here by Kay Moreland about downtown Annapolis that was flooded during Sandy, and she used the hashtag Sandy. Of course, using data from social media can limit the amount of data available, which reduces the scope and dependability of the data, as well as it can be expensive or private and inaccessible. Regardless, FEMA was still able to track real-time citizen responses to identify what areas were still in need of supplies. Not only does this process allow for FEMA to identify where the supplies are still needed, but it provides real-time response to what locations are no longer in need of bulk supplies, allowing for other areas that are in greater need to be serviced. In addition to social media, other data sets can be culled for further highlight areas in need. Several companies are employing electric meters that transmit to a cloud, allowing for real-time data to be collected on the power usage of a house or building. This system can identify what areas are still without power and which have power restored. This simple concept can be vital to managing disaster relief for a specific area. So the methodology that will be used for this example, the data sets of tweets, Instagram photographs, and Facebook posts to demonstrate the power of data mining for specific hashtags and keywords. So unstructured data provides the time and location references to simulate how emergency responses would be able to identify and track those who were still in need of resources. The data sets were imported to HDFS through Scoop, where the data was cleaned and processed for easier analysis. Specifically, the data set was imported from the Twitter 4J API, which resides on the Twitter REST API. These tweets, when they were collected, were used keywords to search for them. Keywords specifically involving Hurricane Sandy were hurricane, Sandy, water, flood, stuck, and help. This data does require the UAuth support, which in order to access it, that is obtained through Twitter's developer website. And I obtained that because I have a signed-in login. It has to be pre-approved by Twitter in order to receive it. The data was also pre-processed using Spark R. I would have removed the URL links, usernames. The nice thing about Twitter is that anytime they're referencing another username, they have an @ symbol in front of it. So it's very easy to locate and remove. Any special symbols, emoticons, stop words such as like, the, for, who, etc., and any retweets. To clean up the data set, the corpus clean package in Spark R was used. The naive Bayes algorithm was then applied to predict whether or not the tweet was a distress tweet involving that event. So I created a training data set to create a classification model to identify distress tweets, and I also created a test data set to validate that model. This is kind of an example of the process where you start with Twitter, the streaming API, bring in the Twitter 4J, API data access. It's then transformed into the specific file, brought into Hadoop and MapReduce, which stores it and turns it into a more manageable process, then converted back into the correct data file, and then applied to the data analysis and any charts that were to be created from that. Further analysis that can be applied to these data sets are that you can geocode the locations with an address locator in Esri ArcMap to display tweet locations. This is where you take a known address locator such as that state's addresses or tax parcels, and you can, as long as they match up with the description of the tweet locations, you can combine them and create an actual layer on a map displaying physical locations of where these tweets are coming from. So if you have a large amount of tweets coming from a specific area within a city, a town, a state, emergency response personnel can then focus in on that area. You can also perform sentiment analysis on tweets to identify any kind of negative connotations. Like I mentioned before, that distress association with those tweets, you can use this analysis to identify. When big data analysis is applied to real disasters, it can be critical to saving lives and extremely beneficial.